For nearly 14 years, NASA's Curiosity rover has been roaming the ancient landscape of Mars, climbing the foothills of Mount Sharp in Gale Crater in search of one answer. Did Mars ever have the right conditions to support life? Now the rover has stumbled upon one of the strangest geological discoveries of its entire mission, a massive field of mysterious honeycomb-like patterns stretching across the Martian surface as far as its cameras can see. At first glance, it looks almost artificial. Some have compared it to a giant beehive. Others say it resembles cracked ceramic tiles or dragon scales. But according to NASA, what Curiosity has found could be one of the most important clues yet to understanding Mars's ancient climate. The discovery was made as Curiosity entered a valley known as Valle Grande, a region scientists have been eager to investigate because orbital images suggested its rocks were unlike anything nearby. On June 19th and 20th, during the rover's 4,930th and 4,931st Martian days, or sols, Curiosity captured an extraordinary 360-degree panorama. Instead of isolated patches of polygon-shaped fractures, the rover found an immense landscape covered in them. These geometric formations extend in every direction, even climbing the sides of a 20-foot-tall butte nicknamed Miraflores. The individual polygons are surprisingly small, roughly 1.5 to 3 inches, or 4 to 8 centimeters, across, but together they create a repeating honeycomb texture, unlike anything Curiosity has previously encountered at this scale. NASA scientists have observed similar polygonal fractures before during the mission, but only in scattered, isolated patches. This is the first time they've discovered an entire sea of polygons. So what exactly are these strange formations? That is where the investigation becomes fascinating. Scientists do not believe these are fossils, biological structures, or evidence of intelligent construction. Instead, they think the patterns were created by natural geological processes that occurred billions of years ago, when Mars looked dramatically different from the frozen desert we see today. One leading theory suggests the polygons formed when wet sediments repeatedly dried out. Imagine the cracked mud left behind after a lake evaporates on Earth. As water disappears, the mud contracts and fractures into polygonal shapes. If this process happens again and again through seasonal wetting and drying cycles, the cracks can deepen, minerals can fill the gaps, and eventually the entire structure becomes cemented into solid rock. Over billions of years, erosion removes the softer material, leaving behind the raised polygonal ridges Curiosity is seeing today. If that explanation proves correct, it carries enormous scientific significance. Repeated wet and dry cycles are exactly the type of environmental conditions that many researchers believe may have concentrated organic molecules on early Earth. Such cycles can create chemical environments favorable for increasingly complex chemistry. While this does not mean Curiosity has found evidence of ancient Martian life, it does strengthen the growing picture that parts of Mars experience dynamic environmental changes rather than remaining permanently frozen or permanently wet. Other explanations remain on the table. The polygons may have formed through freeze-thaw cycles involving subsurface ice. They could have resulted from temperature-driven expansion and contraction of the ground over millions of years. Scientists are also considering sediment compaction and other geological stresses that naturally create repeating fracture networks. Determining which explanation is correct will require detailed chemical analysis and close-up imaging. Fortunately, Curiosity is equipped for exactly that type of investigation. The rover's science team immediately began examining both the polygon ridges and their centers using the alpha particle X-ray spectrometer, which measures elemental chemistry, and the MOLE camera, capable of taking detailed close-up images. Curiosity's ChemCam laser is also firing at selected targets to vaporize tiny portions of rock, allowing scientists to analyze their chemical composition remotely. Each measurement helps researchers determine whether minerals were deposited by ancient groundwater or formed through entirely different geological processes. But the honeycomb patterns weren't the only mystery waiting in Valle Grande. Scattered throughout the polygon-covered terrain are numerous dark-colored rocks that immediately caught scientists' attention. NASA admits it isn't yet certain where these rocks came from. They could be fragments that eroded down from higher layers of Mount Sharp. They might have been blasted into Gale Crater by ancient asteroid impacts. Or perhaps most intriguingly, some could actually be meteorites that landed on Mars long after these rocks formed. Previous dark stones, examined by Curiosity, contained elevated levels of nickel, an element commonly associated with meteorites, but less abundant in ordinary Martian rocks. That makes these scattered boulders another puzzle the mission hopes to solve. The timing of this discovery is especially remarkable. Curiosity landed inside Gale Crater on August 5, 2012, beginning what was originally planned as a 2-year mission. Nearly 14 years later, the nuclear-powered rover has traveled more than 20 miles, over 32 kilometers, across some of the harshest terrain on another planet. Its aluminum wheels now show deep cracks and punctures from years of crossing sharp Martian rocks, yet the rover continues operating and producing groundbreaking science. Few robotic explorers in history have remained productive for this long under such extreme conditions. This latest discovery also fits into a much larger scientific story unfolding on Mars. In recent months, Curiosity has documented evidence of ancient sandstorms preserved within layered rocks, helping scientists reconstruct the powerful winds that once reshaped the Martian surface billions of years ago. Combined with previous discoveries of ancient lake beds, river channels, sulfate-rich minerals, clay deposits, and organic molecules, these honeycomb formations add another piece to an increasingly detailed picture of Mars as a planet that once experienced complex and changing environments. What makes this discovery particularly exciting is that NASA isn't presenting it as a solved mystery. Instead, scientists are doing exactly what good science demands, gathering evidence before drawing conclusions. Every new image, every chemical scan, every laser measurement narrows the list of possibilities. That careful approach may not produce sensational headlines overnight, but it is how genuine discoveries are made. History has shown that many of the greatest scientific breakthroughs begin with a simple observation that doesn't quite fit expectations. The honeycomb landscape of Valle Grande may ultimately reveal nothing more than an unusual sequence of ancient geological events. Or it could become one of the key pieces of evidence helping researchers understand how Mars transitioned from a world with flowing water into the cold, arid planet we know today. Either way, Curiosity has once again demonstrated why this rover remains one of humanity's greatest scientific explorers. Every mile it drives, every rock it analyzes, and every mystery it uncovers brings us one step closer to answering one of the biggest questions in science: what really happened to Mars? And perhaps even more importantly, could the answer tell us something about the history and future of Earth itself?